Good day. In this tutorial video, we will be discussing about hypothesis testing, the t-test. T-test is one of the difficult lessons in the subject of statistics, where some students who have this subject, including me and my group, find it really hard. Before we proceed to t-test, let's have a little background of hypothesis testing. According to the book of Alferez Mary, titled MSA Statistic and Probability, hypothesis testing is a decision-making process for evaluating claims about a population. Which means in hypothesis testing, it begins with the statement of hypothesis, and we need to evaluate the claims in the given statement. For example, a study claims that all adults spend an average of 8 hours on chores during a weekend. So in this statement, we need to evaluate the claims whether the all adults spend on an average of 8 hours on chores is true or not true. So that's the purpose of hypothesis testing. There are two specific statistical tests for hypothesis testing on means, which is the z-test and the t-test. But we will be discussing about t-test. T-test is basically used to tell or compare the two means of two groups or condition or something like that. If there is any difference about the two means or they are statistically significant. T-test is usually used as small sample sizes, which the sample sizes or n is less than 30. This could be a little bit confusing to understand because there are many things that must be considered in this method of inference. You need to list all of the important information like null hypothesis, alternative hypothesis, degree of freedom, and so on and so forth. So for the next part of this lesson, we will be discussing to you the steps of this statistical test.
Now, in this part of the tutorial video, we will be discussing the steps in testing the t-hypothesis. Step 1. So here, we determine the null and alternative hypothesis. The null hypothesis, symbolized as HO, states that there is no difference between a parameter and a specific value. On the other hand, the alternative hypothesis, symbolized as HAA, states a specific difference between a parameter and a specific value. So here in our example, a manufacturer claims that the average lifetime of his light bulbs is 3 years or 36 months. The standard deviation is 8 months. 30 bulbs are selected, and the average lifetime is found to be 32 months. Should the manufacturer's statement be rejected, at alpha equals 0.01. So to determine the null and alternative hypothesis, we should look for the hypothesized mean, which is 36 months. So hypothesized mean equals 36 months. Now for the alternative hypothesis, its its hypothesized mean is not equal to 36 months. So the question is, why why in the alternative hypothesis, why is it not equal? So the reason why the hypothesized mean is not equal to 36 months is because, as stated in the example, a manufacturer claims that the average lifetime of his light bulbs is 3 years or 36 months. So now we're in step 2. So for step 2, we determine the level of significance. So usually, you can find the level of significance in the problem itself. So here in our problem, the level of significance is this, 0.01. So the symbol for the level of significance is alpha, which is this symbol right here. So the level of significance is 0.01. So if it is a two-tailed, you multiply the level of significance by 2, which will give you the answer of 0.02. So now we're in step 3. So for step 3, we determine the critical value, rejection region, and degree of freedom. So before I go over step 3, first get out your t-table, this one right here. So let's begin step 3. So first, we should find the degree of freedom. Degree of freedom. So the formula for the degree of freedom is n minus 1. So n here is the number of samples. So in our example, we have 30 bulbs. So 30 minus 1, which gives us 29. So now we have our degree of freedom, which is 29. Next, we determine the critical value. So in order to determine the critical value, we based it on our degree of freedom and level of significance, which is 0.02. So in this part, we need our t-table. So since our example is two-tailed, here we look at the two-tailed section in our t-table. So our level of significance is 0.02. So we look for 0.02 at the two-tailed section right here. Next, our degree of freedom, 29. We look for it in this part. So 29, 0.2, right here. 2.462. So that's our critical value. 4, 6, 2. Positive, negative, since it's two-tailed. So, so our last part in step 3 is we determine the rejection region. So we draw a normal distribution curve, and since it's two-tailed, we shade at the left and right side of the curve. So this is our T1, this is our T2.
The fourth step in hypothesis testing using the t-test would be the stating of the decision rule. A decision rule is a procedure that the researcher uses to decide whether to accept or reject the null hypothesis. And to be able to make a decision rule, we have to determine first the nature of the normal distribution curve. So there are three main types of tests, and each type has a particular decision. If it is a left-tailed, the decision rule will be reject HO if TC is less than T. On the other hand, if it is a right-tailed, the decision rule will be reject HO if TC is greater than T. And lastly, if it is a two-tailed, the decision rule of both left and right-tailed will be used. After we have identified and stated the decision rule, we will now be computing the test statistic in step 5. A test statistic contains information about the data that is relevant for deciding whether to reject the null hypothesis. And it also measures the degree of agreement between a sample of data and the null hypothesis. And to be able to get the test statistic, we will be using this formula. Sample mean minus hypothesis mean divided by standard deviation over the square root of sample n. In the last step, we will now be making a decision. The decision will be based on the decision rule of the distribution curve and the value of the t and the tc. For example, the value of t is equals to 2 and the value of tc is equals to 1, and we have a left tail. Therefore, our conclusion will be reject HO because T is greater than TC.
In the next part of this video, we would be showing two sample problems.
Good day, this is Jason Verayo here to give you a quick tutorial on how to do the t-test for hypothesis testing. In this sample problem, it says here that in the population, the average IQ is 100. A team of scientists wants to test a new medication to see if it has either a positive, or negative effect on intelligence, or no effect at all. A sample of 30 participants who have taken the medication has a mean of 150 with a standard deviation of 20. Did the medication affect intelligence? The steps on doing a t-test for this problem is first, you have to define the null and alternative hypothesis. Second is to state the alpha, which is 0.05. Third, to calculate degrees of freedom. Fourth, state decision rule. Fifth, calculate test statistic. Sixth, state the results. And seventh, state your conclusion. To start, my technique is to first write everything that is necessary. In here, I have already written the H sub 0 or the null hypothesis and also the H sub A, which is the alternative hypothesis. I have also placed already the alpha, number of samples, which is n, degrees of freedom, which is TF, the t-score, which is the letter T there, and the decision rule reject H sub 0 or the null hypothesis if there. So first step, we are going to look for a null and alternative hypothesis. Null hypothesis mean equal to 100 as stated there above. For the alternative hypothesis, we are going to use here the not equal to or a two-tailed test because in the data it is stated that the test could give a positive, meaning higher than the original IQ, which is 100, or a negative, meaning lower or no effect at all. Next, we are going to state our alpha, which is given, and that is 0.05. N, or the samples, is 30 as stated above. df, or the degrees of freedom, is 29. To calculate for this, you just have to subtract 1 from your sample or from n, which is 30 minus 1, and that is 29. After that, we now need to get our t-score. Since this is a two-tailed test, we are going to multiply our alpha by 2. Multiplying the alpha is only done if we are going to do a two-tailed test. So 2 multiplied our alpha, or 2 times 0.05 is 0.1. With this, we can now get our t-score by looking at our t-table. Now we'd have to locate for the df on the t-table, which is 29, and for our two-tailed alpha, which is 0.1. Making a line to both of them will intersect to a value which will be our t-score equal to 1.6991. To set for our t-scores, we have t1, which is negative 1.6991, and t2, which is positive 1.6991. So now we can set our decision rule, which is to reject H sub 0 or the null hypothesis if Tc is less than T1 or if Tc is more than T2. We are now going to solve for Tc. Tc is equal to the sample mean minus the population mean over the standard deviation all over the square root of sample, which will be 140 minus 100 over 20 over the square root of 30, which is equal to 10.95. Now we are going to check for our decision rule whether we are going to accept or reject the null hypothesis, Tc less than T1 and Tc greater than T2. So 10.95 less than negative 1.6991, which is false, and 10.95 greater than positive 1.6991, which is true. since one of them is true, we are going to reject the null hypothesis. Therefore, to make one conclusion out of many other possible conclusions with the test, we can say that the medication affect intelligence.
Hello, and this is Juris Sanchez, and today I will teach you how to solve sample problems on hypothesis testing using the t-test. And here is our first sample problem. The manager of a car rental agency claims that the average mileage of cars rented is less than 8,000. A sample of 5 automobiles has an average mileage of 7,723 with a standard deviation of 500 miles. At alpha is equal to 0.01, is there enough evidence to reject the manager's claim? To solve for this, let us first identify the given. First is the mean, which is equal to 8,000. The number of automobiles, which is 5. Our sample mean, which is 7,723. Our standard deviation, which is 500 miles. And our alpha, which is equal to 0.01. Now that we have identified the givens of the problem, we can now determine our h sub o, which is mu is equal to 8,000, and our h sub a, which is mu is less than 8,000, which is a left-tailed test. And for the degrees of freedom, we subtract the number of automobiles to 1 to get 4. To get the t, we need to refer to our t distribution table. Look for our df, which is 4, and our alpha, which is 0.01. And since we are using left-tailed test, we refer to the one tail, and which gives us negative 3.747. And our decision rule will be reject h sub o if tc is less than t. Now we need to apply the formula to solve for our t-test. Now we get our sample mean, which is 7,723, minus our mean, which is 8,000, divided by the standard deviation of 500, divided by the square root of our number of automobiles, which is 5, which give us the negative 1.24. And now we have to go back to our decision rule to check if we have to reject or accept our h sub o. Since negative 1.24 is greater than our t, which is negative 3.747, our conclusion would be accept our h sub o since tc is greater than t. Therefore, the average mileage of cars rented is less than 8,000. And that's how you solve sample problems on hypothesis testing using the t-test. Thank you.